Question 2b, it says the line y equals ax plus b is a tangent to the graph of this function here, and the point is 2, 3, and we've got to find the values of a and b. Now, nice and straightforward to do actually, because if we want to find what the gradient of this, because this is just from y equals mx plus c form. So if I was to say, well, if y is ax plus b, and I differentiate y with respect to x, I just get a. So that's our first step. Now, if we take this function here, and I'll write it out here, so y, the other y that is equal to 2x squared minus 3x plus 1, and I find the gradient function of this one. So I'll call this y1, by the way. I call this y2, just for a bit of fun. D, and put y2 there. This is over dx. This is going to equal 4x minus 3. But we know x is going to be 2. So if I substitute, so I put let x is equal to 2. So I'm going to substitute 2 into this. Here it is. So I'm going to have dy, that's a 2, over dx is equal to 4 times 2 minus 3, or 8 minus 3, which is going to be 5. Which means the gradient, because I'm going to put here, because the two gradients must be equal, a must equal 5. So we've got our a value. Now we've also can find nice and easily, I think, our b value. Now, we know, for example, that y is a plus b. If I put a 2 in there, and I put a 3 over here, so we've got y is ax plus b. And we know that y is 3, x is 2, and a is 5. Let's go ahead and do that. So this is 3 is equal to 5 times 2 plus b. So we've got 3 is equal to 5 2s are 10 plus b. This implies, therefore, that b must equal, if I took 10 off both sides, b is going to equal negative 7. So a is equal to 5, and b is going to equal negative 7. And that's how we do that one.